Expanding question number 1, function hx, which is x squared, and has been transformed to gx x squared minus 4x plus 5, and we want to see the transformation between hx onto gx. So method 1, you can graph both functions in your GDC, and then what you can check is the common point between these two functions. Alright, this is what I get from my GDC, and the common point down here for hx is 0, 0. I'm taking a minimum point, and the other one, the minimum point is 2, 1. Okay, so from these two, you can see how from 0, 0 to 1. Alright, there are two movement or transformation. So from 0, 0 to 2, 1. So it moved 2 units to the right. From 0 to 2 for x-axis. So this is 0 and this is 2 units to the right. And from 0 to 1 is 1 unit up. So the transformation is a translation, 2 units to the right and 1 unit up. Okay, question number 2, exponential graph y equal a b power x plus c and passes through 3 points, 0, 9, 5, 1,703, 8, and 45,929. So what you can do is you substitute each coordinates into the function, the exponential function given here. Substitute the x, for example, the first one, you substitute x as 0 and y as 9. And then you do the same for the other 2 points, and we are going to get 3 equations. And then from there, let's see how we solve the 3 equations. Alright, I have written 3 equations here. So equation 1, equation 2, equation 3. Where this equation coming from? From the function given, and after we substitute each coordinate. So the first one, substitute y 9 and x 0. Equation 2, y is 1,703 and x 5, and I did the same with the equation number 3 here. So how to solve these 3 equations? First, equation 2 minus equation 1. So we can see from here, we can minus. So c and c minus gone. And then on the left side, 1,703 minus 9, we're going to get 1,694. And then what happened here? B to the power of 0 is 1. So it's actually just a here. So a, b power 5 minus a. So we can't do anything at this stage. The most we can do is we can factorize. A, b power 5 minus 1. Okay, we take out a and then 1,694 on this side. That's the most we can do. So we're going to stop here for 2 minus 1, equation 2 minus 1. So you're going to do the same with 3 minus 1 on the right side here. So what happened is c and c cross out, c minus 1 cross out, and then 45,929 on the left side minus with 9. So we're going to get like 45920 equal to a b power 8 minus a. Yeah. So and then again, so what we can do here is we can only factorize. So this will be 45920 a b8 minus 1. Okay, this is the most we can do now. So what's next is we divide these two together. Why? Because we want to eliminate a. So if we divide these two together, so then we can eliminate a and then we can solve for b. Okay, so this is how we are going to get after we divide the left side, 3 minus 1 with 2 minus 1, and then that we can cross out a, because a divided by a is 1. At this stage, you can solve this using GDC. So you can use and solve on your GDC, and then you will get b equal 3. So this is the first value you are going to get. So once we have 3, when we have the value of b, so we can easily solve value of a and value of c from the previous equation. So the equations that we had. So this is b equal 3. We will substitute into here. Okay, so next value we will get is a. So let's see what we are going to do. So we substitute into that. That will be 1694 equal a. And then 3 to the power of 5 minus 1. And then you use calculator. You are going to get a equal 7 here. So this is the two values that we get. Now to find c, it's easier. So you can substitute into equation 1. Where's our equation 1? So this is our equation 1. So you can substitute into 9 equal a plus c. So that makes 9 equal 7 plus c, and then we get c equal 2. That's how we get all the three values. So with this substitutions of the coordinates, and then subtract two pairs of equations, and then we divide the equation that we simplified, and from there we can get the value.